Question 5. This question is about the chemical properties of chlorine, sodium chloride and sodium bromide. Sodium bromide reacts with concentrated sulfuric acid in a different way from sodium chloride. Write an equation for this reaction of sodium bromide and explain why bromide ions react differently from chloride ions. So you've got to learn the equation. So sodium bromide and concentrated sulfuric acid make something called sodium sulfate, bromine, sulfur dioxide and water. Sodium sulfate is NaSO4, Na2SO4, because SO4 is SO4 2-, and sodium's in group 1 forms a 1+ ion. A 1+ ion, you'll need two 1+ ions to balance out the 2- charges on the sulfate ion. And you just got to learn that it makes bromine and sulfur dioxide and water. Why does bromide ions react differently from chloride ions? It's because they're further down the periodic table, so they're bigger, they've got more shells, and if they've got more shells, the more easily they lose an electron more easily because they're larger, so the outer electron is lost more easily because there's more shielding and they're further away from the nucleus. The colourless solution contains a mixture of sodium chloride and sodium bromide. Use an aqueous silver nitrate and any other reagents of your choice. Develop a procedure to prepare a pure sample of silver bromide from this mixture. So you've got a mixture of sodium chloride and sodium bromide, and you've got to try and make silver bromide from this mixture. Explain each step in the procedure and illustrate your explanations with equations where appropriately. So the first thing is to add the silver nitrate. You add the silver nitrate to the mixture, and it's going to make two precipitates. It will make silver chloride and silver bromide. Silver chloride is a white solid, a white precipitate, and silver bromide is a cream precipitate. And you can actually write the two equations of that to support that as well. So AgNO3 is silver nitrate, NaCl makes AgCl, and NaNO3 sodium nitrate. Silver nitrate and NaBr sodium bromide makes silver bromide and NaNO3 sodium nitrate again. Next, you've got to find a way of separating these two. So what you can do is you can add dilute ammonia. Dilute ammonia will dissolve the silver chloride, the AgCl, but it won't dissolve silver bromide. To dissolve silver bromide, you need to use concentrated ammonia. So dilute ammonia is going to dissolve this. If you dissolve it, the silver chloride dissolves. You can actually write an equation for that as well. AgCl plus NH3 makes AgNH3 twice, plus Cl minus, so you can need two NH3s. And next, finally, so you've got the silver bromide, which hasn't dissolved. You're going to filter it off, filter the precipitate off, wash it and dry it. Write an equation for the reaction between chlorine and cold sodium hydroxide solution. Give the oxidation states of chlorine and each of the chlorine-containing ions formed. So chlorine and sodium hydroxide, NaOH, would make NaOCl and NaCl and H2O. So if the Na is there, it would be Cl2 plus NaOH makes NaOCl and NaCl plus H2O. But as an ionic equation, you don't involve the Na. You just Na is plus, so you'd have OH minuses, OCl minuses, ignoring the Na plus. This must be OCl minus. NaCl must be Na plus Cl minus. And then you're going to need two OH minuses to balance up the two O's and the two H's. What oxidation state is this in? Well, Cl is in -1. O is in -2. If there's one minus left over, that must be in +1, because -2 plus 1 leaves -1 left over, and Cl minus is just on its own, so that's in -1 oxidation.